Okay, let's talk about formula making and dot and cross diagram. So let's start with aluminum oxide. So if we want to make a dot and cross diagram of aluminum oxide, what should be the first step? The first step, you go to the periodic table, find the symbol. So aluminum symbol is Al, and then oxide, that comes from oxygen, so you just take the symbol of oxygen from the periodic table. Now the second step is find their group number. Aluminum belongs to group number 3, so as it belongs to group number 3 and it has a charge of 3 plus, it means it has ability to lose 3 electron. Oxygen belongs to group number 6, so it has a charge of 2 minus. That means how many electrons gained by 6 electron to become 8 electron, right? So it is 2 minus. Now we make their ions and we just cross multiply them. Now we get the formula, that is Al2O3. Now why there is a need of formula making? Why we are doing this? You can see we have aluminum atom and we have oxygen atom. In aluminum atom we have 3 electron in the outermost shell, and in oxygen atom we have 6 electron in its outermost shell. So it required 2 electron to complete its outermost shell to make it 8, and by losing 3 electron its previous shell is complete, so it will lose 3 electron to complete its outermost shell. But the problem is this will lose 3 electron and this require to gain 2 electrons. Now what we will do, we take 2 aluminum atoms and 3 oxygen atom. In this way the loss and gain of electron become equal. If each aluminum atom loses 3 electrons, these 3 electrons are lost by aluminum and these 3 electrons are lost by aluminum. And now you know this aluminum will become what? It become aluminum ion and it has a charge of 3 plus. In a similar way, it also have a charge of 3 plus. Why? Because it loses 3 electron. So how many electron altogether lost by aluminum? 6 electrons, right? And in a similar way, these 3 oxygens required altogether 6 electron, but each required 2. So these 6 electron will be accommodated 2, 2 and 2. So you can clearly see that these 6 electrons, 3 from here and 3 from here, has been accommodated 2 electron here, 2 electron here and 2 electron here. Now instead of writing 3 times oxide ion, now this become oxide ion, so we need to put bracket and we need to write it. So that is how we make a dot and cross diagram of aluminum oxide. But instead of writing 3 times oxide ion and 2 times aluminum ion, we just put 2 here and 3 here and we get the structure of dotted cross diagram of aluminum oxide. You can see we just put 2 aluminum ion and 3 oxide ion. And now you better understand that why we are doing this. By just, it has to lose 3 electron to complete its outermost shell and it has to accept 2 electron to complete its outermost shell. But there is a problem of 1 electron. To balance number of electron, we cross multiply, and cross multiply mean the charge of ion remains same, it is 3 plus, but this number indicate number of ions. We take 2 aluminum ion and we take Al2O3 mean we have to take 3 oxidine. So you know this 3 indicate the number of ions, and this 3 also indicate the charge of neighboring atom. Okay, charge of neighboring ion. In a similar way, this 2 indicate number of ion and charge of neighboring ion. I hope you understand the dot and cross diagram of aluminum oxide. Clearly see that their number of electrons. 2 aluminum ion lost 6 electron, 2 3s are 6 electron, right? So here 6 electrons are lost, and you can also see that this is 3 and this gains 2 electron, so 3 2s are 6 electron. They are basically gained. So 6 electron lost, 6 electron gained, and they are equal. So this is our dot and cross diagram. Formula making is meant for balancing the number of electron. That is why we just in some cases we put 2, some cases we put 3. H2O, why we write H2O, why we write HNO3, why there are different number in subscript. Why we are doing this? Why? Because we just need to balance the number of electron.